Hello, my name is Pavel Kovac. I work for SOS Electronic. The company is an international distributor of electronic components, mainly for electronic industry. Our company is a part of Conrad Electronics since 2013. I would like to dedicate today's event for communication modules. I have invited our reliable and long-term partner, Quectel company. This company is represented today by Mr. Radu Igret. Quectel company is a worldwide biggest supplier of communication IoT modules, and we at SOS Electronic work with Quectel since 2012. Today's topic are LPWA modules, and Mr. Radu Igret will show you BG96 module in practice. So please, Radu, it's your turn now.
I'm Radu. I am a field application engineer for Quectel, and I support the Southeastern Europe. So Romania, actually I'm based in Romania, Timișoara, Romania, Hungary, Bulgaria, Slovenia, and Croatia. Today I will introduce you in the low power wide area technology, and we'll also have a demo with NB-IoT. So let's see first how the cellular network evolved from 2G. They introduced Edge, so it was a middle between 2G and 3G, and 3G, then newer technologies in 3G to support higher speed, and finally 4G, or as you know it, LT, which means long-term evolution. LT has some more categories like Cat 1, Cat 4, Cat 6. These categories tell information about the supported download and upload speed. So LT supports different modules which are capable of higher or lower speed. And finally 5G, which exists today. But for 5G, they need to reuse some frequencies from all the technologies. This is why 2G and 3G technologies will disappear in the near future, up to 2025, because they need to reuse the frequencies, or operators want better networks to maintain. At 2G, for example, it's much costly for them to maintain. So in the end, they invented two new categories called Cat MB1 and Cat M1 to replace existing devices, that support existing devices in the industry that up to now were supported by 2G. So in the future, there will be only 5G, which will include also 4G. So this will be also safe for future devices to include all these categories. Let's focus now on these new categories called LTM. This is the, let's say, the commercial name, and NB-IoT, narrowband Internet of Things. In let's say more technical terms, Cat M1 is called also EMTC, Enhanced Machine Time Communication. Why narrowband? You can see here, for example, comparison between a wideband and a narrowband. In the long distance, if we want the signal to reach over long distance, the signal to noise ratio could be higher than the useful signal for a wide range, wideband signal. So in this case, we cannot communicate. But a narrowband, which needs lower throughput, lower speed, could use even lower energy to go over this noise margin and have useful communication. For example, if you compare a flashlight, like a 1-watt flashlight, which is quite powerful, if you compare the beam of such a flashlight and the distance where you can see it, it's like, let's say, maximum 10-20 meters. But if you use a laser beam, like 10 milliwatts or even less, this focused laser beam, even if it has 100 times less power, it could reach a much farther distance, like hundreds of meters. This is why they focus on narrow band for communication in case of industry devices that need low throughput and low speeds. So if we want to compare these new categories, Cat M1 and Cat MB1, with the current Cat 1 to Cat 4 and categories, this is how it looks like. So today you would have a Cat 4, even Cat 6 for smartphones to transfer video and data, or other streaming, or other high data streaming, or even for surveillance systems. Cat 1 is used for vehicle tracking. Cat 1 it exists everywhere there is LTE coverage. And then two categories, NB1 and Cat M1, are used for different applications. Like NB1, it's used for stationary applications like parking meters, water meters, lighting, where such devices do not move or move at slow speed, like below 30 kilometers per hour. Or for slow-moving devices below 100 kilometers per hour, we can use Cat M1, even if let's say the throughput is the same or the speed is the same, because the devices move. Cat M1 it's better for this point of view because you can maintain the connection during the handover from one cell to another. So for example, this speed limit refers to how the speed limit of maintaining the connectivity. Like for example, if you have a video call and you are moving fast in a vehicle, it's not acceptable for the call to be interrupted and then reestablished a few seconds later, or even less than a few seconds later. But for NB-IoT, for devices that transmit data each once per month, like for example for water meters, there's no problem if the connection can be established now. It can be established later in 10 seconds and it will be okay. Same for Cat M1 devices. For heart monitoring or other tracking devices, they only need to report data from time to time. If they cannot maintain any connection, they will reconnect. Also for Cat 1, for vehicle monitoring, but for video calls, this is not acceptable for this. So this is the explanation about the speed. When they designed NB-IoT, they had in mind this for areas. First of all, improved indoor coverage. So NB-IoT is better with 20 dB than GSM. This is so you can pass to two concrete walls, because typical applications for NB-IoT are water meters, which are underground in basements, or 3 times the range. This is what actually 20 dB would translate in real language. Massive connections, because the aim is to have one cellular modus, one SIM card for each device, so each water meter. In urban applications, urban areas, one can expect to have multiple devices connected to the same cell. So this technology needs to support massive connections up to 100K per cell. And of course, low cost. So the aim is to reduce the cost to be able to include such cellular device in each cellular module in each device. In the beginning years, 2016, the cost was $10, and now it's much lower. And the last one, power consumption. The idea is to last a minimum 10 years on a battery only. For example, for water meters, they don't have a source of electricity, only local battery. Cat M1 adds all those features and has all those features, and adds a few more, like low latency. So for NB-IoT, typical latency is 100 milliseconds to 15 to 10 seconds. Usually it's the order of hundreds of milliseconds. While for Cat M1, it has standard LT latency like 10-15 milliseconds. Sorry. And also mobility. So NB-IoT doesn't support mobility, doesn't support handover when the device moves from one cell to another, while Cat M1 supports this. But if the movement speed is below 100 kilometers per hour, higher speed, because the higher bandwidth, Cat M1 can support up to 1 megabits per second and supports voice over LTE. NB-IoT doesn't support voice. This is one major advantage of Cat M1. Now let's explain the technology. We see here the 2G technology. Just a reminder how it works. First time the device is powered on, it searches for the cell, and it's doing this on high current peak up to 2 amps. Then after it found the cell, it attaches and transfers the data. Then it can remain in a period called discontinuous reception, eDRX, where only receives signals from the network from time to time, not permanently. And then if you want to reduce the power consumption, you need to cut off the power of the device. So in this period, the device is not reachable. Next time you power on, it repeats the same process, search the cell with high power signals, so it consumes a lot of current, and then the cycle repeats. Then if we compare the same with low power wide area technology, first difference is that high peak current is much less, 250 milliamps or even 200 milliamps, so 8 to 10 times lower than in 2G. Then the search and attach process is done only once, so network registration is one time only. After the cell is found, it is used in the later connections. Well, after data is transferred, same as for 2G, the eDRX phase. But then the second difference is called PSM, power saving mode. So the device itself would shut down and consume a very low current, 4 microamps, so you don't have to cut off the power. This 4 microamps or even lower is comparable to leakage current of the switch transistor you would use in 2G to shut off the current, the power for the device. Then next time it wakes up, it doesn't search the cell again, because on the operator level it's already registered. It just connects, so it's connected or not connected. Does a short sync with the network. It transmits a small amount of data for the update of the network. And if there is no data to transmit, then it remains some time in the page monitoring mode, and then goes to PSM again. If any time the application wants to send some data, it can wake up the device from this mode, send the data, and then repeat it. So power consumption is much better handled in this case. This eDRX time is called idle time, has specific values described in 3GPP standard. Also, the PSM time is the difference between traffic update area time and idle time. The tau time can reach up to 2 weeks or even longer, while the idle time is in the range of seconds and tens of minutes.
Rather, if you compare power consumption of NB-IoT and Cat M1, could you compare it in power saving mode, for example?
In power saving mode, it's the same, because the module is the same, and when it's shut down, it's the same. When they transmit data, it's the same because they both use the same power range. The difference could be in the page monitoring part, where the NB-IoT device doesn't need to be available all the time, while a Cat M1 device does, let's say, more sync with the network, so the network can know the status of the device. Compared to 2G, this monitoring is much more frequent, so that the network will know anytime the status of the device. But for a device that is stationary, for example, for NB-IoT, then device is there, the network knows that is a NB1 device, so it will not search for it, it will not page it so often. So consumption difference is in reception state, but it's quite similar. The coverage is the highest difference because NB-IoT can have a better coverage in low signal conditions than Cat M.
And as far as I know, also the NB-IoT networks are more developed in Europe than Cat M1 networks.
Yes, because they are preferred by the operators, because to deploy NB-IoT, it can be done over a time slot of for 2G, while because it has the same bandwidth, below 200 kilohertz. But for Cat M, bandwidth is 1.4 kilohertz, so they need to sacrifice more slots from 2G to implement Cat M. This is why operators don't support Cat M as widely as NB. Okay, so this eDRX time can be extended up to 44 minutes. So duration between two receiving windows can be higher. In this case, device would be accessible more often, but also power consumption is less than in normal way, or higher, but not so high than if you compare with PSM, where the consumption, we can say it's zero. But the advantage of eDRX over PSM is a device is reachable each 40 minutes compared to nothing when device is sleeping. So there are different values for Cat M and Cat NB-1. So for Cat NB-1, it's 2.9 hours between these receiving windows. For Cat M, it's 44 minutes for the eDRX time. Typical applications for NB-IoT are water meters that use UDP. So data that is pushed only to the network does not require an acknowledge back from the network compared to TCP. TCP is also supported, but there are some drawbacks. For example, the context will be lost after waking up from PSM, so the socket needs to be opened again. TCP will consume more power because each packet is acknowledged back from the network, so double the traffic. And the PSM time in most situations is much longer than the keep alive time from the server. So the server may close the connection, and then when the device wakes up, it needs to reopen it. So this takes a lot, again, some time compared to UDP, where the connection is there, just wake up and send the data. This is the current deployment of the low power wide area networks in the whole world. NB-IoT is more spread than Cat M. This is our roadmap for NB-IoT modules. So we have in our portfolio 4 vendors of chipsets that support this technology. We started with high silicon or Huawei with BC95G module that is narrowband capable only. Then followed with BC68, which is based on the same chipset but smaller size. Then Qualcomm introduced their NB capable chip, and we made a model called BG96. This one is a multi-mode module because it supports also Cat M1, NB1, and 2G, and also integrate the GNSS. So it's important that it has fallback to 2G, so it can be used in areas with NB-IoT or Cat M is not yet available, and in the future, then we can use NB or Cat M. Then followed MediaTek. They also had their NB-IoT chip, and we made the module called BC66 and its successor BC66 NA. Difference is that the second one supports NB2, so the standard was improved with higher throughput, improved current consumption, and the other services. Then Qualcomm introduced a new chipset designed specially for low power applications called 9205, and based on this we developed 4 new type of modules, BG96 series, which again support different modes like Cat M, Cat MB, EGPRS and GNSS. BG77, which is has a super compact size, so it's the smallest module that supports Cat M and MB2. And other variants, we made it incompatible with other popular modules we have in our portfolio, so to be easily replaceable. And lastly, we have also in our portfolio Unisoc, a Chinese manufacturer that supports modules that have that support MB plus 2G, so have fallback to 2G. We can see here that there are 2 types of footprints. So this supports future-proof compatibility. So our customers can start designing for 2G modules like M95, 3G, and also replaced on the same footprint other modules like BC95 for NB, BG96 for Cat M and Cat NB, and even standard LT, Cat 1 and Cat 4 modules like EG91 or EG95. In the other smaller form factor, we can also support migration from 2G MC6 module to current B66 or BC68 modules. Here we have some highlights about the BG96 series. So this one replaced BG96, sorry. It has a compatible footprint on the pin side. The package is a bit smaller. Let's say on the application side, it's the same, but main difference is in price and in current consumption. So BG95 consumes about 3.4 microamps in PSM mode, and supports also voice over LTE. It's in the next demo, I will show you BG96, which is similar, just consumption in PSM is a bit higher because it was first NB-IoT module designed by Qualcomm, and it was actually a scaled down version from a Cat 1 module. So BG95 is actually redesigned from 0 for low power applications. Do you have some questions here?
Yes. Can you tell us about the BG95 with the Wi-Fi integrated? I cannot see it in the list here.
Okay, it's called here MF.
MF.
Okay, so it's supported. Is mentioned here Wi-Fi positioning. Wi-Fi is used only to scan available Wi-Fi access points, and then they scan for a MAC address of the access points, and it uses the information to enhance the positioning feature of the module using an external database of MAC addresses and positions from Google or third-party providers of such services. You cannot use Wi-Fi for data communication, so only for monitoring access points. That's it.
Okay, thanks.
Okay. Next, I will show you a demo using this BG96 module demo board. You can find documentation in below link. And what we will do, we will send UDP data through a server in the internet. Server runs on a Raspberry Pi, which implements also a MQTT client that will connect externally to external broker, cloud and MQTT. It's the free service. And with publish information as we transfer initially over UDP, and then all clients which subscribe to this information will be able to see it. So we will be using a laptop or a smartphone as a client.
So this is how our EVB looks like. This is the box. Let's see what's in the box. Flyer with instructions, how to connect, and some accessories. Some are optional. This is the evaluation board itself. First, connect the RF cable. Make sure it's connected tightly. Then screw the antenna. And finally, the module on a TA adapter board. Snap in on the two connectors. Then connect the RF cable. This is more delicate, so take care. Now I will connect the USB serial cable, this main UART on the left. Then for power supply, we will use USB on the bottom. We can also use standard DC adapter, but 5 volts, not standard, the one provided in the box. Now put the SIM card before you turn on the module. And this is the board. Okay, this is the live demo part of the webinar. You can see here the QCOM application already up and running. Let's load some scripts from here. I created for you a script with the comments already set up, so you don't have to type anything, just click these buttons. But first, open the communication port, turn on the power of the board, and press the power key to turn on the module. Wait for the module to boot up. Okay, module is up and running. Now we'll execute some commands here on the right to change some default values of some parameters. So the device will search and attach to NB-IoT network faster. So first command, set the band to band 20 for Vodafone Romania. For other operators, check with them what band they use and check the manual what value to use here for that band. Next one, change network scanning mode to LTE only. Change network scan sequence to NB-IoT to have priority over Cat M1 and 2G. Change IOTP operation mode to NB-IoT only. And change service domain to PS only, because LTE only uses a packet switch domain. Now enable some notifications. This one enables notifications when the module is registered to the network. This one enables notifications when module is disconnected or connected from the network. And finally, this one will notify when the PSM timer expires. And all those notifications will use UART1, because UART1 port is used for AT comments in this example. Now turn on the module and set the APN. This value is very important for the device to work. So APN is you can get it from operator, specific to each operator. Next one, execute manual registration to Vodafone Romania on 9 means NB-IoT network. So module is already registered. We've got OK here. It may take some time until you get OK. So don't execute other comments until you have an OK here. Next one, we can check some status. So this is actually our 4 comments online. CGAT means 1 means module is attached. CREG1 means module is registered. Some network information, so Cat M1 network, Vodafone Romania on LTE band 20, and this is the channel number used. And this column will output the IP address of the module, IP assigned from the network. Now let's activate the PDB context. When we work with data, we need to have a PDB context active. And now open a connection to a server. So this is a UDP connection to this server, to this port. Actually, here on the left is a window that will show us live data to this remote server. Okay, now we'll send some data, we'll send some text information encoded as hex with this comment. Its data is received by the server, showed here. This is a public API from the server. And we got here a URC, meaning we have incoming data on socket 0. So use this comment, read data on socket 0, and we receive 24 bytes, and this is the actual data. What we sent was replied back from the server. This is an echo server. And now we can close the connection. So this is a simple test to show UDP data sending and receiving on NB-IoT network with BG96 module. Now we will make a test for direct MQTT data sent from the module side. Let's switch first on this window. This is an MQTT client connected to an MQTT broker server. Subscribe to topic temperature. Okay, so we'll make a connection to the same server. It's connected. Now we'll authenticate with username and password. We're okay. We subscribe to the same topic temperature, and we got the same value because now the module is also client to this network and subscribe for this topic as the left window. But now we'll publish on the same topic. So publish on topic temperature. This command will open an input, activate the input mode, and we need to enter here the value by hand. So change it to 21. And now we need to do Control Z. So characters 1A in hex, it's Control Z. And now the data is published, and you see it's already updated on the server side. And because we're also subscribed to the topic, we get the same data back. Now you can close the connection. So this is it. This is how you send data using MQTT protocol with BG96. Thank you for listening. We are waiting now for your comments and questions.
Thank you, Radu, for your presentation. So we now are familiar with the comprehensive portfolio of LPWA modules from Quectel. If you have any question regarding modules, regarding NB-IoT, Cat M1 technology, please do not hesitate to contact our company with your questions. We will help you with your development. If you have application where you will use LPWA modules, you are welcome to contact our sales department or our technical department, and we together will help you with your application. So thank you once again, and we'll see you soon.